Alright guys, so I apologize for not being here today, but unfortunately I'm at the dentist getting a root canal. I decided to record myself going over the homework in case you guys had difficulty with it. It's really important that you master this because the assignment that you're going to do today is based on you doing these stoichiometry problems. So let's start questions that I assigned from pages 388 to 396, questions 4, 12 to 16. Starting with question 4, I've already gone ahead and written the action on this piece of paper, but I'm going to read the question to you. Question number 4 gives me this equation, and what it asks me to do, first of all, is to balance it. So let's start. To do any stoichiometry problem, you always have to start with a balanced chemical equation. You'll notice that this right now is not obeying the law of conservation of matter. There are 2 carbons on the left, but only 1 on the right, so I'm going to fix it by putting a 2 in front of the CO2. And now I notice that there are 4 carbons on the left, but only 2 on the right. So I'm going to put a 2 in front of the H2O. And if you look, I've got a total of 4 plus 2, 6 oxygens on the right-hand side. To fix that, put a 3 in front of the O2. So after balancing, what the question asked me to do was to interpret balanced equation in terms of relative numbers of molecules, moles, volumes of gas at STP, and masses of reactant products. All right, so let's start with the mole part. The mole part's easy. For every 1 mole of C2H4, you end up requiring 3 moles of O2. You make 2 moles of CO2 and 2 moles of H2. Right? If these are all gases at standard temperature and pressure, if we want to describe the volumes, then 1 liter of C2H requires 3 liters of oxygen. You make 2 liters of CO2 and 2 liters of H2O. Write the word mole up here so you see. Alright, and then finally in terms of masses, well, let's figure out what the mass of 1 mole of C2H4. To do that, you would take 1 and you would multiply it by the molar mass of C2H4 off the periodic table. That, off the top of my head, is about 28 grams. For the oxygen, it would be 3 times the molar mass of oxygen off the periodic table, and that's 32 grams. And then for carbon dioxide, that would be 2 times the molar mass of carbon dioxide off the periodic table, and so that would be, let's see, 32 plus 12, it's 44 grams. And then finally this one, 2 times 18 grams, which is the molar mass of water off the periodic table. Why am I multiplying by 1, 3, 2, and 2? Because I already told you guys that that was 1 mole of C2H4. 1 mole weighs 28 grams. There were 3 moles of oxygen you needed. Well, 3 moles is 3 times 32 because 1 mole weighs 32, so 3 moles would weigh 3 times. That's why you multiply, is because you're factoring in the total number of molecules that you would need according to that recipe. All right, so let's take a look at question number 12. Question number 12 gives me a new reaction. It gives me the synthesis of aluminum oxide from aluminum and oxygen. And what it asks, question number 12, for part A, is how many moles of oxygen are required to react completely with 15.8 moles of aluminum. So you see that I have the fence post set up with the given value in the upper left-hand corner and the unit for what they want to write on the far right. And you notice when they ask how many moles of oxygen, I didn't just write mole O. I wrote mole O2 because that's the way it was written in the formula. All right? Okay. If the number that I put in the upper left-hand corner is in moles, then I'm allowed to use the mole ratio. Okay, well, the mole ratio would have the unit mole of aluminum in the denominator, mole of oxygen in the numerator. The relationship between these values comes from the balanced chemical equation, from the coefficient. So the coefficient in front of O2 in the balanced chemical equation is 3. So I'm going to put a 3 in the numerator. The coefficient in front of aluminum is a 4, so I'm going to put a 4 in the denominator. And then I'm going to go ahead and take my calculator and do 14.8 times 3 divided by 4, and I'm going to round my answer to significant figures just like the given. The answer that I get is 11.1. Alright. For question B, they tell me that I'm starting with 78 moles of oxygen, and again I wrote O2, not just O, because oxygen in the equation is written O2. I have to stay consistent with the way the compounds are written in the equation. They want me to figure out how many moles of aluminum oxide you would make if you started out with that many moles of O2. So again, if this number in the upper left-hand corner is already in moles, then you're free to use the ratio.
Alright, so the mole ratio will have moles of O2 in the denominator. It will have moles of Al2O3 in the numerator. Well, the relationship between those compounds, I find that out by looking at the coefficients in the balanced chemical equation. So it's a 2 in front of Al2O3, so that's what goes in the numerator. It's a 3 in front of the O2, that's what goes in the denominator. So 0.78 times 2 divided by 3, and I round my answer to two significant figures like my given, is 0.52 moles Al2O3. Alright, let's take a look at question 13. Question 13, I have a new reaction. They tell me that I have this compound, calcium chloride, and the formula for that is CaC. And it reacts with water to make acetylene gas and calcium hydroxide. My equation's balanced, so I can go ahead and start. In part A, well, there's only one part of this question. They tell me that I'm starting with 5 grams of calcium carbide. They want me to figure out how many grams of acetylene I make. Well, here's the problem. I put my given in the upper left-hand corner, but it's not a mole unit. And there really is no unit that I like more than the mole. So the first thing that you have to do, you're not allowed to use the mole ratio until you get this number in mole units first. How do we do that? Well, I'm going to have to first convert to mole. My conversion factor is going to have grams of CaC2 on the bottom, mole of CaC2 on top. Remember, back in chapter 10, we learned that for every 1 mole of CaC2, the grams we could certainly calculate very easily just by looking up the molar mass off the periodic table. I'm going to grab my periodic table, and I'm going to calculate 1 calcium plus 2 carbons. Okay, so that molar mass is 64.10. Because remember, I told you when you take numbers off the periodic table, try to take 2 rounded decimal places. Alright, so grams of CaC2 cancel out with grams of C2, and now I've got this substance in a unit that I can work with, the mole. Alright? Once you have that substance in mole units, now you can use the mole ratio. Alright, so the mole ratio would have mole of CaC2 in the bottom, mole of C2H2 on top. The mole ratio is going to be moles over moles. Alright, so the number that goes in the numerator is a 1 because the coefficient in front of C2H2 is 1. The number that goes in front of CaC2 is a 1 because that's the coefficient over here on the far left in front of the CaC2. Alright, so moles of CaC2 cancels out with moles of CaC2. But notice there's still a problem. I'm still not done because they didn't want the answer in terms of moles of C2H2. They wanted the answer in terms of grams of C2H2. And so we're going to have to use the periodic table again to do that final conversion back to grams. Alright, so in the bottom of that last piece of the fence post, I'm going to put 1 mole of C2H2. And by definition, I know how much 1 mole weighs. I can look at my periodic table. And I'm going to basically take 2 times the moles of the mass of carbon plus 2 times the mass of hydrogen, the molar mass of C2H2. So 2 times 12.01 plus 2 times 1.01 is 26.04 grams of C2H2. That unit cancels out with that one. And you'll notice the unit that's left behind is grams of C2H2. So what am I going to do with my calculator now? I'm going to do 5 times 26.04 divided by 64.10, and I'm going to round my answer to the same number of significant figures as my given. And so the answer that I get for this is 2.03 grams of C2H2. Alright. Okay, let's look at the next one. Question 14 asks to use the exact same equation as in 13, but now instead of given grams of calcium carbide, they give me grams of water, and instead of being asked for grams of acetylene, they want me to simply give moles of calcium carbide. So first things first, I look at the given in the upper left, I put the unit that I want to get to on the far right, and I notice that this is no good. And it's no good because it's not a mole unit. So again, before I use the mole ratio, I have to change that mole. All right, so how am I going to do that? I'm going to use a conversion factor that has grams of H2 on the bottom, mole of H2O on top. The instrument that tells me the relationship between the moles of water and grams of water is the periodic table. All right, so I'm going to use the mole mass from the periodic table. I know that 1 mole of water weighs 18.02 grams. Okay, what did I do? I took the mass of 2 hydrogens and I added the mass of 1 oxygen to them. I got 18.02. Okay. Now my value is in moles. Now I'm allowed to use the mole ratio. So in the mole ratio, I'm going to put mole of H2O on the bottom, mole of CaC2 on top. The number that goes in front of CaC2 comes the coefficient in front of CaC2 in the balanced chemical equation, that's 1. The number in front of H2O is the coefficient in front of H2O in the balanced chemical equation, that's 2. And these units here cancel out, and you'll notice that the unit that's left, mole CaC2, was what the question was asking for. So I'm done. I don't have to go any further. I'm done. All right, what do I do on my calculator? I'm going to do 49.0 divided by 18.02, take that answer and divide it by 2. And I'm going to round that to 3 significant figures like my given, and the answer here is 1.36 moles of CaC2. All right, let's flip to the next page. Let's do questions 15 and 16. Question 15. I've got some potassium chlorate. I'm going to decompose the potassium chloride and oxygen. They want to know how many molecules of oxygen, and notice again, I didn't write molecules O, I wrote O2 because that's how it's presented to me in the chemical equation. How many molecules of O2 do you make if you start with 6.54 grams of potassium chloride? All right, great. This number is not in the preferred unit that I would like to see in that upper left-hand corner. So the first thing I have to do is change it to mole, because no other unit means anything. You need that beginning unit to be in mole. All right, so I'm going to put grams KClO3 in the bottom. I'm going to put mole KClO3 on top. The relationship between the mole of a substance and the grams of a substance is inherently described in the periodic table. I know that 1 mole of KClO3, okay, I got to take the mass of 1 potassium plus chlorine plus 3 oxygens. I think that mass is 122.55 if I've done this math correctly. All right, so grams KClO3 cancels out with grams of KClO3. I'm left with moles. All right, now I use the mole ratio to stop talking about KClO3 and start talking about O2. So mole KClO3 goes on the bottom, mole O2 is on top. All right, the numbers that go here come from the coefficients in the chemical equation. So you would put a 3 in the numerator, you would put a 2 denominator. These units cancel out, but now you look and see this unit that's left after everything is canceled out is the mole. That's what I wanted. I wanted molecules, so I got to go one more step. All right. Well, that last step involves convert from moles to molecules. Well, what do I know? Definition. 1 mole of anything has how many molecules in it? 6.2 times 10 to the 23rd. So the final step is to multiply Avogadro's number. So in my calculator, I'm going to multiply the numerators, multiply the denominators, and take the product of the top and divide it by the product of the bottom. Whatever answer I come up with, I'm going to end up rounding it to 3 significant figures, just like the given. Alright, and I get 4.82 times 10 to the 22nd molecules of oxygen. Alright? Okay, next one, number 16. Number 16 is a new equation. I'm starting 5.0 times 10 to the 22nd molecules of NO. They want grams of NO2. Again, this is not the unit that I prefer to see in the upper left-hand corner of a fence post. I would really prefer to see the word mole there. If it's not mole, I get it to mole before I can use the mole ratio. Alright, so that means I have to multiply by some sort of conversion factor, get rid of the word molecule, and we'll leave the word mole. Alright, by definition, 1 mole of anything has 6.02 times 10 to the 23rd molecules. Remember, we are dividing to go towards the mole. Molecules of NO cancels out with molecules of NO. Once I'm in mole, then I can use the mole ratio that will allow me to stop talking about one compound and start talking about a separate compound. Alright, so the mole ratio over here is going to have mole of NO on the bottom, mole of NO2 on top. Alright, the coefficient in front of NO2 is a 3, so that's the number that goes in the numerator. The coefficient in front of N is a 1, that's the number that goes in the denominator. Alright, these units go out, but look, I'm still not at the unit they wanted. They wanted me to go to grams. Now I'm going to have to get rid of mole and leave grams. I know 1 mole NO2. I know I can figure out mass by looking it up on the periodic table. So let's see, 14.01 plus 2 times 16. That's what you would do to calculate the molar mass. 46.01 grams. Mole cancels out with moles, and that would leave me a final answer in grams of NO2. Alright, and so again, I would take product of the numerator and divide it by the product of the denominator, round my answer to 2 significant figures in this case, like the given. See, the given only has 2 significant figures. And I get 11.5, which would then round to 12. Oh, I'm sorry. The question gave me 5.00, not 5. So it's 3 significant figures. So then you write 11.5. Okay. All right. If you need to get the answer key, I've left it. However, at this point, I'm going to go ahead and do a Sage and Scribe. So you're sitting in partners. One person is going to have a blue paper. That person will do the odd questions, and they'll have the answer to the even. The other person in the pair will have a pink paper. Person will do the even questions, and they'll have the answers to the odds. Alright? You can keep these papers, you can write on these papers. You don't need to leave them behind. But you can do it one of 2 ways. One person could do question 1 while the other person listens, and then you can take turns back and forth going through all 8 problems, or you could choose with your partner to do questions 1 and 2 at the same time and then answers and help each other, and then move on to questions 3 and 4, and then 5, 6, and 7, and 8. Whichever way you want to do it is fine by me. I don't really care. Just get through these problems, please. And then tonight for homework, you're going to have more same, because you really need to master the questions. The questions that you have to do are in the back of the book, and there's an appendix, and the appendix is called Appendix D. The page number, it's weird, it's page R59, and you do questions 112 to 118, just the even number questions. And that information's on the board as well. Alright, I'll see you guys Thursday and Friday.